those who are new to us, we are data science. So we do a lot of corporate training. If you have a company and you want your employees to get trained in data science, we're a go-to place for that. We teach weekend and evening courses on data science using two languages, R and Python, and we also teach courses on Hadoop and Spark. And the other thing that we do that hopefully will be very relevant to some of you here is we run a boot camp. So it's a 12-week, very intensive, immersive program to train people with very strong backgrounds to become data scientists in 12 weeks. I think any one of them will tell you that they've never worked harder in their lives, and the learning curve is very steep. And by the time they're done here, they are hit the ground running, ready to go data scientists. We are having a party next Tuesday night where we have invited all of our friends who we call hiring partners. We don't charge anything if you hire one of our people, but we call them hiring partners anyway. So we're having a party for anybody who's interested in hiring a data scientist. You're welcome to come to that party. Claire's in the back. If you're looking to hire a data scientist and you want to come to our party, make sure to contact Claire at the end of the presentation so we can make sure you get an invitation. So business being done, I'd like to introduce you to Stephanie Toper, who is Director of Portfolio Analytics at PortfolioEffect. She has such a long curriculum vita, has been so successful that I've asked her to introduce herself because I would get it all wrong. So please welcome Stephanie Toper.
Hi, so I'm Stephanie Toper. I work for PortfolioEffect. So previously I worked as a quant developer for hedge fund and banks in C# mainly. I developed several quant libraries more for fixed income, but here it's more equity. So tonight we're going to talk about high-frequency portfolio backtesting and multi-constraint optimization with PortfolioEffectHFT package for R. So first, what is PortfolioEffect? So we provide 3 main services. So backtesting and optimization. We have 4 API for that. You can use R, Python, Java, and MATLAB. And we also provide some databases. So those databases we calculate using our platform. We calculate risk end of day, and it's available on Quandel, and you can have those databases. So let's begin first. So PortfolioEffect allows to have risk intraday. To have the risk intraday, we need to have high frequency market data. So when I mean to have risk intradays, we can have risk every transaction, every second, but you can choose your windows. If you want to have risk every hour, every 2 hours, every minute, you can choose, you can control. So first, in the risk theory, everyone is using modern portfolio analysis. Modern portfolio analysis is based on low-frequency data. So, for example, when you calculate the value at risk, we will calculate the value at risk end of day, the one yesterday and the one before, and we'll have one data point. So we are wondering what's happening during the day and how the value at risk evolve. Sorry. Oh, sorry. Can you all hear me here? At the back? Can you hear me? Okay. So I was saying that modern portfolio analysis is based on low-frequency data. So value at risk can be calculated end of day. So we'll have today, yesterday, and the day before, and we'll have only 3 points. So we are wondering what happened during the day. For example, imagine you have a flash crash. You will just have your value at risk end of day. It will be too late to decide how to hedge or to do anything. So we want to know what's happening during the day and how it happens. So for that, we'll need to use high-frequency market data. So what do I mean by high-frequency market data? So high-frequency market data consists of observation with near transactional resolution. So for example, tick-by-tick data or limit order book data are example of high-frequency data sets. For example, if we have like an illiquid symbol, even if we have just few points during the day, it's still high frequency. But if it's very liquid, you can have like hundreds of transactions in 1 second. So that's high frequency data. So comparing what is low frequency data. Low frequency data is a subsample. So for example, end of day data is like low frequency data, or like if you take every n minutes. So if you do that with liquid stacks, it can remove certain transactional effects. And we know that low frequency data is what is used currently in finance, and it's been a very long time we are using that in portfolio analysis. So how can we use those high frequency market data? So first, let's see like in the history. So Markowitz in 1952 he created the modern portfolio theory. Risk Metrics created their methodology in the 90s, and CAPM was introduced in the 60s. So what all those models have in common? So I mean it's old. It's been like it was developed like 30 years ago. The most recent models. Nothing was developed after. So what do we do traditionally? We take the portfolio position, the low frequency data, and we apply modern portfolio theory, and we'll get portfolio metrics. However, algo trading is growing and grew a lot since the past decades. For example, in 2005, 56% was machine trading, and now, not now, but in 2013, 86% is trading. And you can see that the number of shares, here it's 2.5 billion. In 2005, it increased in 2013 to 6.6 billion. So it means that trading with the computer increased more than like 70% through like 10 years. So those numbers are taken from Credit Suisse and their work group. So, so more and more machines are trading. So we need to have those data more and more fast. So exchanges and broker will adapt, and they build very fast infrastructure. So now we can have high frequency data. Like 30 years ago, 10 years ago, we didn't have access to this data, and it's why modern portfolio theory didn't like improve, or we didn't develop anything. We don't have access to so many data. So now like we can have low latency and throughput data distribution very fast. So there is several myths about high frequency data and how to deal with them. So one of the myths, which is like known by a lot of people, think that's true, but that's not. It's a myth. So let me read it. So data frequency does not need to exceed rebalancing frequency. Trading portfolios that are rarely rebalanced may use low frequency returns to compute their intraday end of day metrics. So what does it mean? So if you have a portfolio and it's not rebalanced a lot of people think, oh, it's okay, we can just use low frequency data and just use the data with the frequency of the rebalancing. So let me explain you why you should not do that. So first, as I told you before, it's new. We have high frequency data now, and before we didn't have access to them. So something you have to keep in mind is, for example, if you have data trading, like high frequency data, and you decided to take only end of day data. So it means you are taking only 1 point instead of 23,399. You are discarding a lot of points and a lot of behavior during all the day. The same if, for example, you take a 15-minute sampling period, and you will discard like 99% of all the data. So if you do that, smaller sample may result in lower statistical significance of estimate. So like as we know in statistics, if we take less data, our estimates will be like less good. Metric like Sharpe ratio, expected tail risk is conditional value at risk, beta and the rest have very rich intraday dynamics, and I will show you later. They will not be able to be, the dynamic will not be able to be captured if we use low frequency data fully. Like the dynamics will not be fully captured if we use low frequency data. And the more low frequency data points are used from previous trading day, the less relevant is the metric value at the intraday daily horizon. So what do we mean by that? For example, risk metric will calculate the value at risk with the past 150 days. So it means like we'll have like data from the past for 150 days. It's not going to show exactly what we have now, or like in the future, it will predict less what is happening because we're using a lot of history, which is less relevant.
So are you considering only IIDs here?
Yeah, no, so welcome, it's not So yeah, so here like portfolio effect HFT is going to they're going to take care, like we're taking care of the noise, of the non-normal process, and all this. Everything is taken care, so it's not ID. We're taking the real log return, the returns, and we and all the model is created. Welcome. So I mean, here it's like R code. I will come back later how to use a package and how to do it. And you can see this is a market beta. And for Apple, Google, and a portfolio composed of 500 share of Apple and 600 of Google. And I mean, here you don't see, but here you can see. You have 3 days. So 11 of January, 12 of January, and 13 of January. So you will have 3 points. And you can see if you were summarizing the beta only with 3 days, you will have only 3 points here. And you can see you have very rich dynamics of the beta throughout the day. The same, this is like a chart with Sharpe ratio. So it's calculating for like 11 of January, 12 of January, and 13 of January. And throughout the day, you can see we have very rich dynamics, Apple, Google, portfolio. So the second myth is high frequency returns just mean more data and are not structurally different from low frequency returns. One could continue using traditional risk model, simply replacing the data inputs. So what does it mean? It means a lot of people think that if you take high frequency data, you put it in your model, like the classic models, we'll have result and we'll have the high frequency risk. That's not true. In high frequency, you will have a lot of noise and a lot of issues you have to deal with. So let me explain you what you need to take care of. So I mean, PortfolioEffectHFT package is taking care of all this, and the model already developed. So first, you have a lot of noise from the BDASK bonds. You can have irregular time interval between observation, the EPS effect. Volatility clustering and low memory and absolute value of return, non-normal asset return distribution. As you know, like even so, like a lot of theories based that the asset are normal is not true. You have fat tails. So here we're taking care of the fact that you have fat tails. You have time-dependent parameters and high computational load related to big data problems. You have a lot of data you need to calculate fast. So how do we deal? We'll take the portfolio position, the high-frequency data. We apply high-frequency microstructure effects models on those high-frequency data, and we put it in the modern portfolio theory. So we'll have the portfolio matrix. So I mean, you need like a because we have high frequency market data, if you have like a flash crash or anything like this, we'll be able to see, we'll be able to react faster. You will see like how like the matrix react. So let's see how to use the PortfolioEffectHFT package. First, I mean, you can install it using install.package PortfolioEffectHFT. So it's available on Chrome. So why did we develop like another backtesting framework? So I mean, they already have a lot of backtesting framework like performance analytics, portfolio analytics, F-portfolio. but they all use low frequency input. So what is very specific here is we use high frequency market data input, and we can give you high frequency intraday risk. You can also use, if you want, as I say, end of day, because with our methodology, even like if we calculate end of day or like 1 hour, we benchmark it against risk metric methodology, and we still have better estimates. Because we'll not use 150 days, for example, to calculate the value at risk. We'll not use 150 days in the past, but we'll use an optimal window. Because we have so many data, we don't need to use all this fast, which will give you the best estimate. Also, in this backtesting framework, we take care of all the model issues. So we use a pipeline of high-frequency market microstructure models to enable update resolution of 1 tick for both risk performance metric and for portfolio optimization results. Right now, if you like subscribe, you will have like 8,000 data on US equity covered by the Nasdaq. I mean, this is a paid version, but we have also a free version. You will have, of course, less data, but you can still play with it, and it's very interesting. And as I say, we have like 4 API: MATLAB, Java, and Python. This is like if you want to do backtesting or optimization. And we also have already calculated data end of day, which are available at Quandle. Yeah, and like, I mean, you just need to subscribe online. You will have an API key, and you'll be able to play with the R package. So as I tell you before, PortfolioEffect integrates a set of automatically calibrated model into a streaming pipeline to process high-frequency return and produce intraday real-time portfolio risk metric. So we are taking care of the microstructure noise model, the non-Gaussian returns model, the price jumps, and outlier model. So what do I mean by jumps? Is, for example, holding overnight. Like, let's say the price of IBM tonight is like 200, and tomorrow when you wake up and the market open is at 300. Fractal time scaling, portfolio factor model, and spot sensitivity model. All of these settings can be, they have default settings, but we can like also, you can change them if you want. So how do we create first a portfolio? We'll use the method called portfolio create. For example, here it will create from time, so the 8th October 2015 and the 9th October 2015 from 9:30 to 4 p.m. For the timestamp format, you can either use this one, so year, month, day, hour, minute, second, and you can also use this format. So this one will take into account this is the beginning of the trading day and the end, and you can also use T as a current day, and T-5 will be 5 days later. So this function portfolio create will create the object portfolio, and you will have to add position in this portfolio. So if you have single position without rebalancing, to add just one position is very easy. You use a method called portfolio add position. You take your object portfolio that you already created. You use the symbol Google, for example, or you can use any. I think online on the free version you have Google, Citi, and Apple, which are available for free, and quantity 100. And you can plot, and you see that new portfolio, you added the position. If you want to add multiple positions without rebalancing, you can do it in only one line. So you use the same function, portfolio add position. You use the portfolio object you created, portfolio. You will add the symbol Citi, Google, and the quantity, so 500, 600. You can plot and see you will have those two share. You can also add position with rebalancing. So you use the same function, portfolio add position. You will use the symbol, for example, Apple. Quantity, you have 300, and at 2:30 on the 8th of October, you will have only 150. So you can see here like 2:30. So this is a way if you have rebalancing. If you have multiple position with rebalancing, so you will have to create several lines of code. But it's the same principle. So for example, you have Apple at 2:30 on the 8th of October, which will rebalance from 300 to 200, and symbol Google, which will rebalance from 100 to 150 at 2:30 on the 8th of October. So you can see here the sharp at 2:30. If you use in PortfolioEffectHFT package the method show and plot, you will have the summary. So you will see how your portfolio position weight, the portfolio constructed, the variance, the expected return. So it's a good function to know to see what you built. So how do we input market data? So in PortfolioEffect, we have two things. We have client-side market data and server-side. What does it mean? If you are a client and you have your own data and you want to use them, you can, and you will be able to insert them. You can also use, I told you we have 8,000 NASDAQ equities available. So if you want to use this one, they're already on the server and you can use this one. So it's more, it's faster, it's already there, but it covers only US equity. So let's say you want to do, you apply this on oil, gas, or like FX, you will have to upload your own data. So if it's client-side market data, how does it work? You will have to respect the format. So you will have the timestamp, the value, and you will create a vector. So here it's an example how to download it. So first you create your portfolio create. For example, we say I'm using SPY as the index. We are using single index model, so it will all covariance matrix correlation will be based on, for example, SPY by default, but you can change. You can add position, so Google, Apple, and I mean when you call Google.data or Apple.data, this is the data you provided. So so that's just an example. You can, I don't know, you can do like IBM, you create your data and you can input it. So it means you can upload your own data and we'll do the calculation for you of the risk. Server-side data. So what do we have? We provide to 1 second the intraday bar historic for all NASDAQ traded equities, which have 8,000 symbols. Here, the frequency is 1 second, but our platform is able to do intraday. It's even able to do every tick, every transaction, which can be smaller than 1 second. But we realize that most of the clients need maximum 1 second, so for now we provide only 1 second. Some people just like end of day and all this. So right now, the data from begin at 2013 until now. So if you backtest, you can use until 2013. You can use also later, before if you want, but you just need to ask us. And you have real-time data, so you're trading now, so you have now the data. So if you are backtesting with the server side, the data are already on the server, so it's faster than downloading your own data, the calculation. So how do? You will do a portfolio equal portfolio create. Index XPY. So from time, for example, 8th of October 2015, 9 October 2015. So how you create portfolio, already told. And you add position, city, Google, Apple. And those symbols is already in the server, so you don't need to call any vector to create. We will know what it is, and you can say what's the quantity and if you want to rebalance or not. So if you want to know like how many symbols, what do we have? You can just call the function, the method portfolio underscore available symbols, and it will tell you what do we have. So for example, we have bioshare, biotechnology, clinical trial fund, steel case in common stock, and yeah. So you can see what we have. We have mainly the NASDAQ one. You can also like have a hybrid market data. So what do we mean by hybrid is you are going to use your client-side server and what we have also on the server. So let's say you have your own data on foreign exchange in China, you want to upload it. You will upload it, you will also upload the data which we already have on the server, which has a NASDAQ. It's already there, so you don't want to upload it, you will use them. So how do you do it? So the same principle, you create your portfolio. You can choose portfolio setting, we will come back later on it. So we have default portfolio setting, and here we chose that the window length will be like about 1 hour. So server-side prices, no rebalancing. So we'll add position, so SPY, CT, 500, 600. So this is on the server side, so we don't need to give any vector. If on the client side prices, no rebalancing, we give the vector google.data, so we'll know what to use. And you can use also, and you can use also rebalancing. So we told like, I mean, this is timestamp GTC, but you can use also the date if you want, from to and to. And you download the apple.data, so you input your data. So you can upload your data, so you have more than 8,000 stock on the NASDAQ. So what portfolio metric do we have?
So here, every calculation happens on your servers or
Yes.
on locally
So
on your computer?
no, it's on our server. So when you calculate, you will it will go on our server. We calculate and we give it back to you. So portfolio metrics. So what do we have? What portfolio metrics do we provide? Transactional and near transactional sampling frequency. So 1 second prices, market microstructure noise could amount up to 50% of total return variation. Noise levels in high order moment estimate with high frequency data could be even higher. So more you use high frequency data, more you have noise. So we have to deal with noise. So to deal with noise, we will compute position metering using online learning model for market microstructure noise and equidistant rival to mitigate estimation bias due to high frequency microstructure. So when we say inequidistant rival is we don't have the price arriving in the same time, but we still need to provide a risk. So for example, we provide the variance. So position variance, portfolio symbol Google. So market index XPY explains 30% of all intraday price variation for a large sample of stocks. And we don't take into account beta spread, limit order, book liquidity, which is less than 6%. Right now, we are not using multi-factor portfolio models because they are very slow and will not be able to provide you intraday risk if we use multi-factor portfolio models. You will not be able to calculate as fast. So it's why we are using a single index model. So single factor model, it means. So we reduce dimensionality when estimating portfolio moment and derived metrics. For example, like to calculate value at risk, you will need to calculate the full covariance matrix. And so it's why we use single index model, so it goes faster and we can provide intraday risk. So so as I say, we produce a variance. We produce, I think, over like 40 different metrics. So we have we're getting high frequency market data and we're giving you high frequency risk, and you can choose the window, so you can have less fast if you want. So we have return, expected return, upside return, downside, Sharpe ratio, Kalman ratio, Sortino ratio, omega. We have relative risk measure, beta, covariance, correlation, tail risk measure, variance, conditional value at risk or expected value at risk, star, shape. So you can see all the functions you need to use to call them. So you will use the portfolio you created, you will input it, and you will get your results. And we have more. We have like Jensen alpha, tremor ratio, information ratio. So this is relative risk adjusted measure. We have also absolute risk measure, variance, curvature, kurtosis, downside, upside variance, and we have fractal measure, Hurst, fractal dimension. So it's a very exhaustive list of risk metrics. For example, here we plotted some charts and portfolio Sharpe ratio. So we can see CT is in dark green, portfolio light green, and Google is blue. So Google will impact more the portfolio, and you can see the Sharpe ratio from 10 a.m. to 4 p.m. the first day, and here until the next day. So it's covered today, and you can see Sharpe ratio is very rich intraday. So I mean, like in modern portfolio theory, usually we calculate return end of day. So we say return. We'll have one data for the return and one data for yesterday, and we'll do a log, and you will get only 1 point. So here we have, like you can see, it's very rich. So if something happens in the market, you can react appropriately and fast enough. Let's say you have a news announcement or something happen, you will see new variance go up or down, and you can react. This is a plot on sorting ratio. So the same portfolio, CT, Google, and you can see here. Value at risk. So for confidence interval is 95%. You can choose. This metric was calculated and calibrated for 95% interval, but our model allows to have. You can choose any confidence interval, and you can have intraday. This metric doesn't provide intraday. So yeah, the same. So you can see from 10 a.m. to 4 p.m. and and you can see value at risk for CT, Google, and the portfolio. And Google, because Google is special stock, it will impact more the portfolio. We have also a modified Sharpe ratio. So we think. Yeah. Yeah, it's not in this presentation, but online on the tutorial, if you click tutorial, you will have like a glossary. And on the glossary, you have exactly which methodology we use for any of our metrics and which formula. So you will see exactly what we have. So for any of the metrics, you go to PortfolioEffect.com, you click glossary, and you will have exactly what we mean by single index model, how to use, and all this. Yes. Yes, it is. But you can see the definition, what we mean by Sharpe ratio exactly, what do we use. Yeah, because I mean, it's a lot of studies, like for 4 years, like 4 or 5 people work on taking all these high frequency market data, being able to put it and look at the risk, calculating in noise fast, because you have all this noise to take into account, so it's a lot of work. We provide value at risk, modified Sharpe ratio, CT, Google, the same portfolio, and you can see how the value at risk behave at opening. So, as I said earlier, we have returns and we have expected returns. So, we have skewness and kurtosis. So, for example, if we think our stock is behaving with a normal distribution, it means like the skewness will be 0 and the kurtosis will be 3. And here we calculate the risk intraday, and we can obviously see it's not the case. So it's not normal, and we already know you have like fat tail, so you need to consider that. So so here we have, for example, skewness, CT, Google, and same portfolio built from those 2 stocks, and same kurtosis. So if you want to optimize how you calculate and to calculate it faster, you can send it via a batch. So what do we mean a batch? So you will have, so for example, this is the first line of code I sent without a batch. So we measure the time, start time, and the time taken is to measure how long will it take. So it takes 15 seconds to run a portfolio value at risk with a 95% for a portfolio, and conditional value at risk. And if we use the batch function, so we have portfolio underscore start batch, we have the portfolio value at risk, portfolio conditional value at risk, or expected tail loss is the same thing, and batch and we calculate the time. I mean, here you don't see it, but here you can see it's 6 seconds. So we have this batch, you send it, and it will be faster to calculate. So if you want to optimize the time. We can play with the portfolio settings. So if you want to change the portfolio settings, I mean, you have default one, but if you want to play with the redundancy, the time scale, the noise model, the jumps, the density, the factors model, fractal price, or the drift term, you can change them, and I will show you how. You have also like portfolio metrics, so you can change the portfolio metrics mode, the holding periods only, and the short shell mode. And for the data sampling, you can have result sampling interval or input sampling interval. I will come back later on it, but sampling is just like, do you want high frequency data every second, every hour? So you can change, like if the interval is like the input or like the output. Because we have two things, you can calculate risk with high frequency data and have like your normal end of day risk. Or if you want, you can impact the high frequency data to be slower and have, I don't know, a slower risk metric. We take also into account transactional costs, so you can add them if you want to test how your strategy is working. So portfolio metrics mode. So we have two. We have portfolio and price. So how do you change? You will say portfolio settings. So portfolio and portfolio metrics mode, price or portfolio. So what does it mean? So portfolio metrics are computed using previous history of position rebalancing, and price. At any given point of time, both position and portfolio metrics are computed for buy and hold strategy. So you can see at the beginning, I mean, I don't know if you see that here, at 10 a.m., the blue line is if we run the variance with portfolio, so the light blue. So this one, down, all down. And let's say the dark blue, the black, is the one if we run with price. We can also play on holding periods. So it can be either true or false. So when holding periods only is set to false, trading strategy risk and performance metering will be annualized to include time interval when position quantity were 0. When set to true, trading strategy metrics are annualized only based on actual holding periods. So what does it mean? It means like, let's say I'm holding a stock with a certain volatility for a time being, and I decide I don't hold this stock anymore, so I will hold this stock only for 5 minutes. When I don't hold the stock, my volatility will be 0. So if I'm holding the stock 5 minutes during the day, and during those 5 minutes it spikes a lot, the volatility spikes a lot, if I'm going to sum with all the 0, I will have very low volatility, but does it really mean that I don't have any risk? Yes and no, because you can see, like, you will have no risk if you look at the calendar effect, because you are like, on the day, only 5 minutes it was very high. But if you look inside those 5 minutes, it was very high, so you had like a lot of risk at this point. So you can choose like how you want to measure this effect. So either if you don't want to sum the fact that you have all those 0 because you hold it only for 5 minutes, you will put holding period to true, and it will be like the light blue line, and you will put to false if you want to sum all those 0. So of course the variance will be lower, but at the same time you took a lot of risk during those 5 minutes. So you have to see if it's worth it or not. So yeah, you can choose. We have also result sampling interval. So these settings regulate how results of portfolio computation are returned. Depending on your usage scenario, some of them might bring significant improvement to speed of your portfolio computation. So so for example, result sampling interval 30 seconds. So it means you will have the value at risk every 30 seconds. So it's a dark blue line. and the light blue is every 90 minutes. So if you calculate every 90 minutes, of course, it will go faster than if you calculate every 30 seconds. And you can see that by calculating every 90 minutes, you will lose some of the intraday risk. So depending what you use strategy and what you do, but it will go faster to calculate. Microstructure noise model. So you can either enable or disable the noise model. So default to true, which means that microstructure effects are models and resulting high-frequency noise is removed from metric calculation. When false, high-frequency microstructure noise is not separated from asset return, which a high trading frequency could yield noise contamination result. So as I told you, if you have high-frequency data, you have a lot of noise. If you don't take into account the noise, your data will be biased. And you can see here, for example, for the variance. So if it's set at true, it means that we remove the noise. So you can see your variance is far lower. But if you don't remove the noise, you will have very big variance.
So what is that noise? Just false prices, or?
Yeah, it can be like, for example, the noise. For example, a trader who knows what he's doing, he can drive the price. Or you can have people who don't know what they are doing, and the price will go like crazy. So, like at high frequency, the noise will be amplified compared to like very low frequency. So this is what we are going to take into account. You have also we take into account jumps, outliers. So you have 3 available modes: none, moments, and all. So jumps are like, for example, you're holding a stock overnight. So it's, let's say tonight the stock is trading 50, and tomorrow it's trading like 150. You'll have a jump. So none, so price jumps are not filtered anywhere. Moments, price jumps are filtered only when computing return moments. And all price jumps are filtered from computed return price and all return. So you still use the function, the method portfolio settings, the portfolio created, and jumps. For example, you should choose all. So here you don't see, but in this chart you have the jump model, and you can see if you put none, you are not filtering the noise. You will have the light blue line, so you have this like very big pikes of it. And if you put yes, your variance will be smoother.
So what is the difference about the price jump versus the price noise?
So jumps would be like holding period, and like a jump, like a noise. For example, if you have something during the day which is increasing, quite sharp, it's not a jump. It's like going is increasing. So that's the difference. Like a jump will be like really, like the example is like holding tonight the stock. Here it will not be continuous. But if you see something in the time with like going fast, it's in fact continuous. Like some people can consider it as a jump because they don't have the high frequency data and they don't. They will see like 2 points like this. But in fact, it's continuous. It's increasing very fast. Just. If you want to include the transactional cost, you can use like portfolio settings, your portfolio, transactional cost per share, and transaction cost fixed. So what do we mean by transaction cost fixed? Is, for example, each time you trade with this broker, you will have to pay $1. And per share, also they will charge you each time you trade like IBM or like another one, $0.005. So that's the difference. Here you will have like the charts for so high frequency portfolio, low frequency portfolio, and if you don't have buy and hold portfolio. So for example, if you trade a lot on a high frequency portfolio, it will cost you more than if you trade on a low frequency portfolio, because you will be always charged this fixed cost, and you will be charged per share. Yeah. We also provide portfolio optimization. So with the PortfolioEffectHFT package, you can do portfolio optimization. So I don't know if you know what's optimization, but so you have an equation to optimize and you have the constraint. So we use a multi-starred approach to compare local optima with each other and select a global optimum. Local optima are computed using a modified method of parallel tangents, Parton. Optimization algorithm require a single maximization, minimization goal to be set using optimization goal. So I will show you after. And return optimization object could be used to add optional optimization constraint and then pass to the optimization run method to launch portfolio optimization. So you will have the object optimizer. We'll use like optimization goal method. We input the portfolio we created. The goal is to optimize the return and the direction maximize.
So what is deduction?
I mean, you can minimize.
What is deduction?
You can maximize or you can minimize your portfolio. You can choose, do you want to maximize your return? Yes. But do you want to minimize your value at risk?
Also the goal can be value at risk.
Here we say, so the following portfolio metrics could be used at optimization. So you have variance, value at risk, conditional value at risk, expected loss, the same thing, expected return, Sharpe ratio, modified Sharpe ratio, star ratio, constraint, like after the mode. So yeah. The following constraint methods are available. So you have optimization constraint all weight, constraint sum of absolute weight. You can have constraint as expected return, variance, beta, value at risk, conditional value at risk, Sharpe ratio, and and portfolio value.
So here you are only calculating same time correlations, or can you calculate lagged correlations, time lag correlations?
What do you mean by time
So
lag?
time series analysis, like an ARMA model, so autoregressive
No.
models, or moving average models, or Gauge models.
So, for example, if you go on our website, they have an example of moving average strategy. So, and if you go on the tutorial on R, I think the first one is a moving average strategy. And
What if you see that your time series is auto-regressive?
I mean, for calculating all the time series and all this, we're not using the classical like ARMA model and all those because it will not work. So I'm not sure. But I can show you like on the tutorials what you have and how.
Can you create your own function? Can you create your own variance function? And,
Of course, I mean you are like I'm not sure it's yes, but you like it's R, so you just download the package. You can use our function, but you can use a lot of different providers. You can even use people who want to execute your trade through R. So you can test, backtest, optimize, and trade with someone else. So you can use whatever you want. Or you can use MATLAB, Python, or Java. So it's really like up to you what you want to add to it.
Cool.
Yeah, and all those 4 APIs, all the functions are named the same. So it's very easy to change if you want to go. You want to test on R, but after you want something developed permanently on Java.
But you said that everything runs on your servers.
Yeah, it's an API. So what is an API is if you provide access to data or like to methodology to people, you will like call. It's like Bloomberg API. I don't know if you ever use Bloomberg API or Reuters API or all this. You will have. They will give you a library. You will just call those functions, and all the calculation and everything is done on Bloomberg server or on Reuters.
So your server side is run on R engine or on different engine? Is everything calculated on your side, right?
Yes.
And what is that R? Is that R on your side or different server?
Yes. I just know all our servers we have.
No, my question is, what did you run on your side?
Is that R more different than C++, I think?
Oh, it's Java, sorry.
It's Java.
Everything is developed in Java, yeah, on the server side. Yeah, the API is just to access the function. I don't know, like, if you use other market data provider, not this very classic way, you just have to check. So here, one of the API, you just download PortfolioEffectHFT package, and you already have all those methods existing, portfolio value at risk. You just have to create your portfolio, put it in the function, and you have your results.
And
That's
if you
called
have,
API.
and if you have your own function, so you want, instead of bar, you have your own function, you want to run that.
Yeah.
So how do you do that? So you define a function locally, and then
I mean, for example,
upload it to your servers, or what's
you want to run without data your function? What do you want to do? Because, like,
And
I
so
mean,
you
you open RStudio, you can install all the package you want. You add also hours. If you calculate value at risk, when you send the portfolio and the time you want, of course it will be sent to a server, it will return you, but it's very fast, so it's like take like 1 second, not even, and you can add your function and calculate what you want on it. It will be on your local machine.
also the data can come to my machine. Your data can be downloaded onto my machine, and I can run my own analysis.
Yeah, I mean, the calculations are made on the server, but you have your result on your computer.
Yeah, but if I have my own function,
Yes, and you want to use the 8,000 stock of NASDAQ? What you mean?
yeah.
Yeah.
And how do I do that? So can I download the data and run my analysis locally on my machine? Or
I don't think you will be able to download all the data because you'll have, except if you pay us like for us to pay the NASDAQ, but to pay you the license. But I mean, we are not data provider. We are providing you the risk metrics. I mean, we have to pay a license to get the data, and we calculate you the risk. But if you have data, you can send it to us, and we calculate for you. This is a client-side server, so if you want to do that, you have your own. This is contrary of what you want, but you have your own data. You can upload that to us. We calculate for you the risk, and we send it to you.
that's clear.
Yeah, but it's not. We are not data. We're not going to give you NASDAQ.
Yeah, but if I have my own model, trading model, so how can I run that on your data? So that's what I want.
And our data is we provide risk metrics, so we'll give you you build your portfolio, and we give you.
Yeah, but these are kind of limited risk metrics. Okay, that I understand.
Yeah.
That these are the ones that are mostly used, but you can come up with your own model.
Yeah, sure.
And then what?
Yeah.
What can you do with your own model? How can you use that in your favor?
So you will want to add more. Okay. I'll think
So
about
let's say
it.
I have an R model. How can I run that on the data that you provide?
Yeah.
So,
I mean, it's like high frequency data, so you'll not want to run NARMA, but yeah, I will come back. I'll get back to you. Okay. So we are in the optimization. So we can have different constraints. So one of them is scalar constraints. So it's like the same place of the optimization. So how do? You will call the method optimization underscore constraint underscore beta. You will have defined your optimizer. We define it above in the last slide. What do you want? You want your beta to be below 0.1. So we optimize, and you can see on these charts, the blue line is the original beta, and this is the optimization. So the beta is below 0.1. So you can have also vector constraints. So instead of using like a single scalar, you can specify a vector of constraint. So for example, you build a beta vector. So you will have from the 8th October 2015 to the 9:30 to 2:30, so the time. So the value will be like minus 0.8 and 0.4. You will optimize, so the same way as above. You put your optimizer, the condition, and the constraint. the condition is below, and the constraint is the beta vector which is defined above. And here you will have the chart. So this is the original beta, and the one under, you don't see fully here, it will be like the one which is optimized. You can also define your own constraint. So user-defined constraint relies on a provided function, which is called during portfolio optimization at specified rebalancing time. So you will define your own function, and you will put it in my constraint, portfolio beta. So for example, here the function is all beta will be -1. So you call the method optimization constraint beta optimizer. So and you have my constraint. And like on the original, this is the light blue line is the original beta, and the dark black is the optimal beta. So let's say we want the beta to be -1, so you can see at the beginning 1.2 minus 1 is 0.2. So yeah, so if you want to play with the API, like it's free, so for like several stocks, so you can just install the package. And we have a lot of tutorials online on PortfolioEffect.com, and it's really easy. Honestly, you just download this user manual, and you just do exactly what is written, the login, and you install. And in the manual, they will explain you like how to create portfolio, add position, exactly what I told you. So you can do it yourself, and yeah, see if you like it. Yeah.
Are there any upcoming features that you haven't talked about?
Yeah, they're like working on like news event, and like because like yeah, depending what clients want, we are more like so a lot of clients are interested in news events, so we are partnering with another firm which do news event, and they're using our tool, and we are trying to like normally like in 1 or 2 weeks they will publish a white paper on how to detect news events with our stuff.
Is the data available in real time? Like
Yes. So yeah, we have historical and real time. So yeah. That's like,
Can I provide my own real-time data?
yes.
The sample showed just
Yes.
a static data file, right?
Yeah. But I think you can.
So I'm just curious, what are your most clients? How do I use this kind of data API?
How do you use it?
Yeah, so what are those your clients currently using your service?
So most of our clients are institutional, so like hedge fund, quantitative hedge fund.
Okay.
But I mean, right now it's more like quantitative because it's the one who have the most access, I understand. But in fact, like even if you use only end of day data or just like every 1 hour, our result and our estimate is better than the classical methodology because we use those high frequency market data. So even if the results is not like every second, our estimates like really like the estimate error is very small. Like we have some paper coming up like comparing like different methodology. And any other question?
So your R source code is publicly available. What does that mean?
I mean, the API is publicly available, yes.
That's good.
I mean, it's like Bloomberg API is publicly available. You can like download the API without any issue. But here you have like, as I told you, like you have the free version. You're like for academics or people, students, or like or just you want to test the product. It's great. You have all the feature, and you have just like the number of time you're calculating is 5 minutes. It's a lot for someone who is just testing and who is not really trading, because it's like high frequency, so we calculate very fast.
So that's the limitation.
But any like when you for the free license, but it means when you send the stuff to calculate. So to exceed 5 minutes, it means you are trading on it. It's like a lot. Because we calculate, you have to know that we calculate our risk matrix intraday with tick, so a tick is less than 1 second, like yeah, you'll get less than 1 second. Yeah.
And does it matter that you have subsequent data or counters that where the people don't care about that, or your clients don't care about that?
What do you mean subsequent data?
Sub-second.
Ah.
So the highest frequency you have is
So right now we have 1 second, yeah. But I mean, it was developed for tick by tick. So if someone needs tick by tick, like let's say tick,
Sub-second.
yeah, sub-second. So it's like a tick by tick,
Or
transactional data. So I mean, if someone needs transactional data, we just like give him transactional. But for now,
But you can handle that.
yes, we don't see the need for
Up to
now.
what?
I mean, every transaction for now, yeah, they developed it for every transaction, so transaction. Yeah. After
No, I mean it depends on your database even. So what your database can handle. Certain databases can even handle subsequent timestamps.
I mean, for example, if you use Bloomberg API, they have real time, so sometimes it's like sub-second, and you get your data. That's all. And yeah.
When you mean tick by tick, it means every transaction, so you can't go lower than that.
Yes.
You know what I mean?
Yes,
I mean,
I understand that, but if you have only second the timestamp.
No, but for the
Okay,
risk.
so how
There's
fine
only
is the
second.
timestamp you're
There
asking?
are many.
No, but that's the risk matrix.
Hmm?
Like we gave you every second the risk matrix, but our data have frequencies that will like tick. So we have two things. So we have like the data and we have the results. So you can choose, as I say, you can choose like the data is high frequency, so it's every tick. If you want, you can choose the sampling. You can have less, but usually you're happy to have high frequency data. And your results, you can choose. You can have every like we give you the smallest 1 second, but you could get every tick, or you can get like every 1 hour. You can choose your window.
Yeah, and what venues do you have data from?
So the data is Nasdaq. I mean, we are not like we're not a provider of data, but you can but we have Nasdaq data. So if you build a portfolio using Nasdaq, you will get you'll get your result. So we cover US equity and stocks, and you can put your own data if you want. So if you I don't know, a trader on gas and oil, you can do that. And we are adding like Canadian currency right now. So that's the next step. But you can add your own data.
So just getting the big picture in terms of client usage, this is portfolio optimization strategies or high frequency trading strategies for like, fast turnover and, scalping type things.
So, I mean, if you're doing high frequency, you can use this tool. But if you are not doing high frequency and you're doing low frequency, the methodology, how the risk is calculated, is different than from the classical modern portfolio theory. And by having this input of high frequency market data, our risk estimates are better and more accurate than if you don't have that.
Okay.
Is it answering what you were saying?
Sort of. I mean, I see. There's a world of high frequency trading where you're doing pairs trading and trying to get first to make an arb between two correlated things, and that requires ultra fast processing. I don't think. My guess is that's not what this is. My guess is that this is superior portfolio theory. Is that right? Am I getting the right feel for what the client usage? This is sort of, portfolio theory plus, as opposed to simple stat R, fast as you can to the market.
I mean, it's both because the only thing we don't provide is execution, but it does like high frequency. So if you see like something ticking right away, if you develop correctly, you can directly trade on that. But we don't provide execution. But if you had the execution, yes. But it was developed for high frequency, so we cover like if you see something in the market and you use our real-time data, you can. You just have to have your computer linked to the market. But you can also use that lower frequency for classical. If you want to value at risk like twice a day or 5 times a day. But I mean, like for any hedge fund, intraday risk, even like, I used to work in fixed income, and for fixed income, just having like the value at risk every 2 minutes, people are so happy because they can see like if something happens, it can react very fast. So.
Are you guys able to make an efficient frontier that beats a classic like a capital market line, or can has it been done, or do you guys happen to have seen like you have the classic frontier with more standard low frequency, and then if you do this methodology with better variance and better, let's say, inverse correlation findings, you could maybe get a frontier that moves outward.
I don't know for the frontier. Like I know, like online in the tutorial, you have different strategy. You can check like what strategy, and you can see the difference, like if it's high frequency, low frequency, and yeah, and you have like maybe.
Cool.
Any other questions? Okay. So.